Today is Sunday, September 21st. Right now, or yesterday, I flew the drone, and I'm unsure what's going on. I switched the polarity for the IMU for it, and for some instance, it's flies, goes up about like from here to here, and then starts going and flips over. But just straight away flips over after it hovers. Um, Possible obscurities. Could be IMU mispolarization, which I'm not identifying well enough, which I recalibrated to reset into a very directional pace. And what also could be was the misdirectional. So what I mean about that is so when it's I can demonstrate it right now. So everything works, communication is good. I implemented more safety procedures when I have the flying some forth. So when it's more than some degree angle, which is about I which I had to adjust it. Originally it was 15 degrees, which just automatically shut down and flipped. But I had to translate that. So I'm gonna turn it on. See, it still works. Decrease, but it's right now it's in hovering. So you see as it shuts down, goes back up, then this increases. At the end it increases so it can like counterbalance itself by some degree angle. And then it hovers, and then I can still I'm gonna lower the throttle. Still, everything's matching perfectly, so. So you hear this increases and so forth. I think what it is that one of these motors are possibly broken. That's the only case. I double checked, asked ChatGPT, asked some friends, and still it's coming close. Sometimes ChatGPT gives me the wrong code and just re-reference because my prompt engineering skills are amateur, but not too good. I had to fiddle with it my own self, and which typically that's most cases. Before, just to make sure is that when you use AI, make sure you know the subject. You do further research into giving yourself a good comprehension of what that subject is. So you can easily fiddle with it because ChatGPT does not know. You cannot be forward direct if you don't know what you're talking about. So but here, what I'm doing right now, so I bought a new frame. I bought a new frame, which is $100 with different motors, which just like before. These are for carrying about 15 volts or 90 volts, and has a brushless motor for it. I bought new motors that are for forgot which one, but it was on Amazon with a frame kit. So it has just the motors in the frame, which I can literally this is too sturdy, but I'm gonna remove all the pieces I have now, put it on that cheap old little thing because I want to do further testing on it. But this is too strong, too expensive, and it crashed it a few times, and it's very tough. I'm telling you, it's a tough ass bitch. But hey, so right now, what I'm doing right now, I'm gonna lower the thing. I'm currently working on a test bench for it. So what I'll be doing is using the Arduino PLC. So if I have this, so I have a potentiometer connected to switches. There will be one switch that's going to be connecting here to switching. So I will have a ESP32 connected to an H bridge, which is a PTS 7960, which with a 12 volt 10 amp supply will possibly get a fuse for it. Power supply directed with a linear actuator towards here. I connect the actuator to the relay outputs, which is not the case because you can't do that. Then have these ports, which is just the PWM. Said, hey, what are some ways, because this expansion doesn't work, what are some ways to get analog outputs with a high current supply towards Arduino if I don't have a proper working analog input for the PLC? So I said, you know what, let me do this. Since the drone I referenced was saying, okay, it uses PWM for the ESCs and the motors itself. So doesn't it have as online? It does. It has analog. So what I'm going to utilize is the PWM signals, LEN and REN, which are the control of the motors. Connect the wires to here. Connect this to the ESP32. As the ESP32, it has digital output, so I've connected digital output to the Arduino Opta main. So, and then connect the potentiometer that I already have here and switches, connect that inside the structural text and ladder diagram, reference the bits, convert the bits and towards some percentage and and you reference it for the potentiometer and just integrate it. Potentiometer, boom, should work. The structural text, just reference it. I already have the program built. Churn, and then sends the signal all the way directly towards the ESP32. ESP32 translates the digital signal towards analog, redirecting the signal. Then the linear actuator should work. That's what this is. Currently the weekend. I did exams, so this is the day. So week 1, 1, 2, 1, 2, 3. Week 2, 4, 5, 6. Week 3, 7, 8, 9. Week 4, 10, 11, 12. So today is day 12 of working on this. This is including just incorporating weekends. Monday through Thursday, sometimes Friday, is school and exams, and I have a job, so taking that time out and working on this. Day 12, weekend 4. Yeah, we'll be working at end of September, near end of September, which is next following weekend. I will be finishing this to a capacity of about 70 to 90% in that margin.